All right, guys, thanks for checking in with me. Remember, I'm still there if you need my help. But as I mentioned, I figured still doing videos works better because that way you can kind of listen to me and go through them and write the notes. Please make sure you have notes out. This is chapter 8, the beginning of chapter 8. 8.1 is a review of Algebra 1. I know we covered a lot of these in Algebra 1, but we're going to go a little bit more in depth and maybe get a little bit trickier on some of them. Please be listening to this and maybe paying attention because when you get the homework posted, which is going to be posted almost right after this, and it's due by the end of our block period, and so I needed to have it turned in before you like leave for the day. But all of the homework looks like my examples, like usual. So anyway, we're going to go through. I got a whole stack of papers here, but it's because I got a couple examples on each. Again, this is a review of Algebra 1. So you are going to have to be hitting pause a lot more often than I am during this. So I'm going to hold up a piece of paper, hit pause, copy it down. A couple of them I have to write answers on and talk to you about, but we're talking about exponents and rules of exponents. So the first one I'm going to remind you of is product of powers. So what would happen if we would have like a to some power times x to some power times another x? Notice our variables are the same. So since our variables are the same, the variable stays the same. It does not become two x's. It is just one x still. Oops, sorry, let me pick a different color so it shows up a little bit better. The answer is still just x. The only way that would be a 2x is if one of these had a coefficient in front of it. Just because you see 2 of them, just because you see 3 of them, just because you see 4 of them does not make the answer 4. X is our answer. If you are multiplying your two variables together, you will add your exponents. So it would be whatever a plus b is. Okay? Product of powers, x to the power of a times x to the power of b would equal x to the power of a plus b. So let's see that in person. 2 examples if you want to write them both down. If you want to hit pause and do that quickly. But what is your variable in example 1? P. So your answer is going to be p. What are your 2 exponents? 2, 4. What is 2 plus 4? Thank you. Notice p to the 6th. There's not 2 p's because there was 2. Your answer is just p. Now down here I did make it a little bit more difficult because there are some problems like this on your homework. But this, notice there are coefficients here. So we're going to work one at a time. If you guys cannot tell me what 3 times 4 is, you're kind of in trouble and you shouldn't be at this point in Algebra 2. 3 times 4 is 12. What is the next variable you see? N. So we're going to write n next. What are your exponents on n? 2. It's a trick. There's a 1 hiding there. You guys all know that. What's 2 plus 1? Thank you. 2 plus 1 is 3. What's my next variable? M. Thank you. What are my exponents on m? 3, 2. 3 plus 2 is 5. So your answer for that example would be 12 because 3 times 4 is 12. This is the part where it gets confusing. We are multiplying the numbers, the actual big coefficient numbers, you multiply them. But the small exponents you add. So again, that was product of powers. Next, what if I have a power of a power? Meaning, what if I would have like a to the power of m, but then there's some parentheses and I'm supposed to take it to another power. Think about this how you would normally think about parentheses. That's what I always like to say. You are going to multiply those together. So I'm just going to write those right next to each other. M times n. Now, because of my examples and what they do, I have a whole nother paper that has another rule. What would happen if there was 2 things inside? Now notice, this one only had 1 variable and it had an exponent on it. But this one has 2 separate variables on the inside. If there's 2 separate variables on the inside, we don't have to do the FOIL method. You would only have to do the FOIL method if there was a plus there. Since there is a times there, we're going to get each of them to the power that's on the outside. So this could get a little bit confusing if one of them had an exponent on it. So that's what I'm going to do here. We're going to look at a few examples with exponents of exponents. So first of all, please remember, if there's more than one thing, each thing gets the exponent. So I'm going to write this out longhand. What I mean by that is I am going to write something out and then we're going to simplify it. So the 2 has to get the exponent, so that's why I wrote 2 to the power of 2. The n cubed has to get the exponent, but the n cubed, excuse me, I accidentally wrote an m right there. The n cubed, remember when there's an exponent of an exponent, you have to multiply them. So now we're going to write our answer right underneath here. I hope you all know that 2 squared is 4. Thank you. Right here it says to do 3 times 2, which is 6. So we would get our answer to be 4n to the 6th. Look down here. The 2 has to go to each part. So the 2, notice it's kind of like I distributed it. Really it is. 4 squared, thank you, is 16. X squared, there's nothing I can do with that. It's already just as simple as it can be. X squared, 4 times 2 is 8. 16x squared, y to the 8th. All right, I got 3 rules right in a row here just because of how, again, they work together and what happens in our examples. So what if I had, instead of multiplication, what if I had division? Well, again, if I pull up that piece of paper, think about it. When we multiplied, we added. So when we divide, we are going to subtract. Thank you. So we would just have one exponent again, since they're both x. We're going to have just x. And our one exponent is going to come from subtraction. So I would subtract those 2 numbers. Now there's a few funny things that can happen when I subtract. If I subtract 2 numbers, I could get a negative answer. So what happens if I have a negative exponent? Well, if I have a negative exponent, it's actually like an okay thing, but I don't want to have negative exponents. It would just mean the only way I could get a negative number here if there was a bigger number in the denominator. And so since there would be a bigger number in the denominator, that means that there would just be leftovers in the denominator. So if you have a to the negative exponent, a is a negative exponent, that just means you have 1 in the top, and in the bottom would be x to the a, but notice the a is now positive. Okay, so if you get a negative exponent, just leave it in the denominator, but leave it as a positive exponent. So what would happen if I would have a negative think about this. Technically right there, you don't need to write this in your notes. The negative exponent was in the numerator, and I made it positive by moving it to the denominator. So this has a negative exponent in the denominator. That means it technically should be a positive exponent in the numerator. All right? So if we do subtraction and we get a negative, that's okay. Just make sure it gets put in the correct place. Since we were doing division, what would happen if we had power of a quotient? That means inside parentheses we saw a fraction. Just like multiplication, we are going to put the exponent on both items. All right, so both the x and the y would get the exponent of m. All right, so let's look at a few exponents, with quotients. Don't get confused here. There's a single 4 right there. So 4 divided by, there's a 1. What's 4 divided by 1? Okay, if there would be a 2 right here, I would do 4 divided by 2. If there was a 4 right here, I would do 4 divided by 4. But there's only that single number, so 4 is going to be a part of my answer. Again, I'm going to kind of do it like as I'm talking 4 divided by 1. But then I would want to think about my p, my variable. And so I would have p to the 4th divided by p squared. Once again, what's 4 divided by 1? All right, 4. What's 4 minus 2? Do you know why I'm saying 4 minus 2? Because p, here the numbers were actually 4 divided by 1. Here it's variables, so I have to subtract. What's 4 minus 2? 4 minus 2 is 2. Thank you. All right, now I have m squared divided by m to the 5th. What is 2 minus 5? 2 minus 5 is negative 3. Thank you. Do we want to have a negative exponent? Our answer says please don't put any negative exponents. So since I have that, it would be 1 over m cubed. All right. A couple other things here to remember and look at as we're working through things. What if we have an exponent of 0? This should make things very, very easy. Any number to the 0 power, besides 0, that gets a little bit tricky. That's a calculus problem, but any number to the 0 power is 1. So in an example or two here, I have something to the 0 power. On some of your homework, I think there's 0 powers. As soon as you see something to the 0 power, I would cross it out and just pretend that it's 1. All right, so those first few examples I gave you, there are some examples, homework problems like that. However, we have a lot of tricky stuff too. Like that's the stuff I'm really kind of worried about, and it's the last few homework problems. So I'm going to give you a few, look at how big, this looks big, bad, and messy, but I'm going to tell you, and I'm going to use some of those Post-it notes like I've used before to help us out. So go ahead and copy down this example. I got extra paper if I need it, but I am going to pretend for just a minute that it's only the numerator. So I'm going to cover up the denominator completely. But I'm going to know that the denominator is still there. So in my work right here, I'm still going to leave a fraction. Sorry, with the light behind and stuff like that, you can still kind of see through, but just pretend the only thing you can see is the darkest thing right now. What should we do if we have parentheses with an exponent? That's right, sort of distribute it. So in the top, I'm going to get 2 to the negative 2. But then I'm going to multiply those numbers. Negative 4 times negative 2 is 8. So I'm going to get m to the 8th. Hopefully everybody can understand why I would get 2 to the negative 2 and m to the 8th. Now I'm just going to take those Post-it notes and I'm going to flip them upside down so that all I see is my denominator. Now if all I see is my denominator, oh look, I have 2 times 2. Anybody know what 2 times 2 is? 4. Thank you. I have m and another m. Remember, if I have 2 m's, my base stays as m, but I add my exponents. What's 3 plus 2? Okay, 3 plus 2 is 5. I have an n and another n. I have 2 variables of n, so I'm going to combine my n's, excuse me. What is 4 plus a negative 2? That is subtraction, guys. You could say 4 minus 2. 4 minus 2 is 2. So right now, I isolated the numerator, I isolated the denominator, and now it looks a little bit nicer like this. And so now I'm going to do a few things. I see, do you guys like having a negative exponent on your 2? I don't either. So that 2 to the negative 2, I'm going to make it positive by moving it to the denominator. Would you guys all agree 2 to the negative 2, if I make the numerator exponent positive, I can just move it from the numerator to the denominator. M to the 8th I like, so I'm going to kind of space things out a certain way too here to help us out. So this is what I had just a second ago. The only thing I didn't really like was that 2 to the negative 2. Since it was 2 to the negative 2, I moved that to the denominator. And then I just made sure to put my m's on top of each other like that so they were lined up. So now I'm going to cover things up. Does anybody know what 2 squared is? But that's 4, and I see times 4. What's 4 times 4? That means I have 16 in the denominator. Since I did my numbers, I'm now going to look at m. What would you like to tell me about m? I have m divided by m, so I'm going to subtract my exponents. What is 8 minus 5? Since it's a positive 3, I'm going to leave that in the numerator. And now I get to my n's. There's only one n. I'm just going to rewrite it down exactly where it is. So my fraction bar is a little bit long. But the answer for that example, even though it looked big, bad, and messy when I broke it up and kind of took my time, the answer is m cubed divided by 16n squared. All right, last example, and then you guys can get started on the homework. Hopefully it will be posted by the time you're kind of getting done and watching this. So the last example, I'm going to kind of do the same thing. I'm going to use my Post-it notes to kind of isolate things for us. Oh, this looks really big, bad, and messy because of that big old cubed on the outside. You could distribute the cubed right away, or I'm going to do something. I don't like those big sets of parentheses right now. So I'm actually going to use my Post-it notes for a few like examples, and I'm going to pretend those weren't there, because if those weren't there, I actually see a pretty simple thing for me to simplify right there. Remember, anytime you see any exponent of 0 that actually equals a 1, so I'm going to cross those two out. I know this was on my original work, and I'm going to make it times 1, because times 1 is easy. Times 1, that's easy. I don't even have to write times 1. So that means right now my numerator just has m squared. Because that was a 1, my denominator just has 2m cubed n squared. Now, technically hiding behind these, and I'm going to move them down along with us, I would have those parentheses with the cube. I wrote them there, sorry. I wrote them there, but I'm going to just move the Post-it note down and pretend they're not there for a minute. Because is there anything you would like to simplify inside here? I agree, you have two variables of m, so we're going to subtract. What is 2 minus 3? Oh, 2 minus 3 is -1. Where should that exponent of -1 be? Yes, it should be in the denominator. So technically when I hold up this paper, I have m to the first in the denominator, but that means everything has disappeared from my numerator. Guys, we've done this before this year. If everything has disappeared from my numerator, that means I have to keep that place. I can't just all of a sudden make the numerator disappear. The numerator has to have a place value of 1. Now, I left the Post-it notes on that paper because there's nothing else I can do inside the parentheses. That means this 3 is the last thing I have to do. And by the way, if I have that 3 there, that means everything should get a power of 3. So there's one thing that I'm going to put a power of 3 on that is sort of pointless, but it's just to help you see that everything is supposed to get the power of 3. Do you see how I put the power of 3 on everything? So now I just have to simplify powers of 3. What is 1 to any power? 1 times 1 times 1 is still 1. This one I'll do a little bit slower. What's 2 times 2? 4 times 2, 8. 2 to the third power is 8. M is just to the third power because there's nothing else there. But n squared to the third power, remember I already put that on there too. When you have those power of a power, you multiply. 2 times 3 is 6. So n would be to the 6th power. And this one does look a little bit messier because the numbers got a little bit bigger, and if you slowly work through it like that, the homework should be just as easy as what I just did. Your homework is due by the end of our block period, which is kind of coming up possibly pretty quick, but at the same time not. I mean, this video is only about 20 minutes long and our class is 90 minutes long. And so you have 70 minutes to be working on that homework now. But before you do that, your job is to click back over to that Google Hangout. It's still there. You can click on that link that's on our Google Classroom page. The homework should be posted. I think I will remember, hopefully, if not, as we're sitting talking, I can remember to upload a Google Doc that kind of puts these rules up there too, just so you have the rules written there, but they should be in your notes. If you look at your notes and examples, you should be good to go on the homework. I'm available on Google Classroom as well. So please work on your homework and get it in. Again, take a picture of it, submit it on Classroom or submit it through email. Doesn't matter to me. Hope you guys have a good day. Ask if you have any questions.